Guys, this is Mr. Post here, and on today's extra help video, the objective is going to be to understand the difference between a chemical and a physical change. So we're looking at matter, and we're trying to see changes in matter and classify them as chemical or physical changes. A physical change is a change in physical state, meaning a solid, a liquid, or a gas. So in here we have the ice cube is solid. It's solid matter. It is being turned into liquid matter. And it also may be evaporating off into the air. And if that's the case, that's evaporation. And then we're going to have gas phase here. Okay, in each one of these phases, I do want to key in on something. We have a change in physical state. The ice cube is H2O. It is water in the solid state. When it melts, it turns into a liquid. But it is still H2O, just in a different physical state of matter. And lastly, when I turn into a gas phase through evaporation, it is still H2O in the gas phase. All right? And each one of these, I do want you to see, it is reversible. All right? It is reversible. And a solid can be changed into a liquid by melting. And it can be changed back into a solid by a process called freezing. And a liquid can undergo evaporation. I'm just going to abbreviate evap. And it can also go back into from a gas to a liquid using the form of condensation. And abbreviate that as well. Something perhaps some of you know is that a solid ice cube can actually evaporate. And when a solid ice cube evaporates and it turns into a gas, well, in this case, it's called sublimation. It could sublime. And it can also go back from a gas directly to a solid. A little less known one, though, is called deposition. But one thing I want to key in on here, the whole entire time, the big player here is H2O. I haven't changed it into any other chemical. It's still two hydrogens and one oxygen the whole entire time. So no matter if I'm going from a solid to a liquid and then to a gas and even back to a solid, it doesn't matter. These are all physical changes. Physical changes are changes in my state of solid, liquid, and gas. And I'm also going to key in on this, guys. Each one of these is reversible. All right, each one of these changes is reversible. Another way I could have a physical change is if I change the shape of matter without altering matter itself. All right, so I could change the shape of matter without altering it at all. All right, so did I alter the chemistry of the candle? Okay, did I alter the chemistry of it? What chemicals make this up? Now, I can't tell you off the top of my head, but I do know that it's going to be a C combination of something with a hydrogen combination of something. But all you really did is that you cut it. You use a knife and you change the shape of it. So in this case, you fall into over here. You change the shape of it. But it is still candle. It's still wax. And I still see it lying around over here. Over here. In this case, could you get it back? Could you get it back to form candle again? I bet if you actually heated it up into a liquid form, put it into some kind of mold of a candle, you can get the whole entire candle back. Now, that's not the case every single time, because certain things like trees and branches that break, those are changes in your physical state, but you cannot get them back. You're not going to melt a tree and get it back to form a tree again. So there is limitations in that analogy, but basically if I change the shape of something, that is not changing the chemistry of it. So that is once again considered a physical change. Okay, a chemical change. Here we go. Chemical change. We're talking about, this is a total change in the way something looks, smells, tastes. It is a brand new object. It's a brand new chemical compound. And in fact, it has brand new chemical properties because of that. All right, so here we go. Fire, anything that burns, all right? Something that is burning is a chemical change. There's no way you can get that wood back to its original form. It is not reversible. We're talking about these are permanent. All right? You cannot get this egg back into the shell. You're not going to get all the yolk back to being nice and clear. and I'm sorry, the yolk, egg whites being nice and clear. This is something that's totally brand new happening. You're going to notice that heat was involved. Heat is given off in this case. Often you're going to find that heat is given off or heat is taken in. All right, so something that burns, something that is in the process of sorry for those lines, they're decomposing. All right, you'll notice when I said chemical properties in the past, I said something could decompose, maybe something could burn. In this case, something is reacting. It is in the process of it happening. All right, these are chemical changes. Let's see. Can we think of any more? Total one-way reactions. I think of a great one here. Happens all the time. Digestion. There's no way of getting that back, all right? These are all something brand new is being formed. It is not reversible. This is different than a property. A chemical property said something could burn, something could decompose, something could react, something could digest. I'm telling you, something is happening here. So this is the actual act of these things happening. Okay, here's a great compare and contrast between a property and a change. Let's look at a physical property. In this case, the object of matter. We're studying matter. Once again, the object of matter we're looking at, it's going to be an ice cube. So let's take a look at our ice cube. Let's look at properties of matter. Properties of matter are descriptions of matter. How am I going to describe it? It's cold. It's solid. It's clear. It's colorless. It's odorless. I'm using my five senses. It tastes like water. No taste whatsoever. How about this? It's 30 degrees Fahrenheit. I can put a number there, for it. That's great. I could say it's actually 0.99 grams per milliliter of density. So I can throw numbers in there also. Okay, that's a property. Have a change. Okay, an ice cube could melt. Okay, if it melts, it turns into a liquid. I could actually change the shape of the ice cube by taking a hammer to it and crushing it. All right, so here's a physical change. Physical change in both cases is still H2O. Nothing has changed that. I haven't somehow sawed off the H from the O. They're both together still. So you have melting is going from a solid to a liquid. That's still H2O. Breaking or shaving the ice cube, guess what? I'm still H2O, just a different shape. And a little compare and contrast. In this case, we're going to look at a chemical property and a chemical change. And we're going to take into account here matter. And the matter that we're trying to look at is going to be firewood. Okay, cool. All right, so a chemical property of firewood is that it is flammable, meaning that it can catch on fire. All right, it can burn. I'm not saying it is burning. I'm saying it can burn. Okay, what else can I say? I say it can react, or it will react. It's not reacting yet. It will react to undergo combustion. It will rot, and it can be digested. Yes, it can be by termites. Okay, those are properties. I'm trying to describe the firewood chemically. It can undergo all these changes. I could also put down, let me add one more here. I can also say it can not rust. It can't rust. Now, on the other hand, what is the actual change? Let's talk about how we're going to change this thing. When the log is actually on fire, it is burning. Okay, when the log is actually rotting, that is different than it will rot or it can rot. When the log is actually being digested, it's in the process of it. So a change talks about the change happening. The property describes how it can happen, not that it is happening. Okay, just definitely a night and day over here of something that can happen or something that, excuse me for that, is happening. Something that is happening. Okay, guys, that's all for chemical and physical properties, chemical physical changes, okay? Hope you got everything out of it. There's a little control bar at the very top. Please rewind to the beginning of the lesson if you need to hear it again. See you later.